so this experiment is one I came up with on my own, and so what I have here is a container full with water and then cold water, and on top is a dollop of shaving cream. Right here I have red food coloring, and then I have a thermostat, and on the side over here I have my heater. And so basically, the first step is basically to make, this represents the cloud, and underneath is the atmosphere. So if I could get this lid off, there we go. I'm gonna first, this is not gonna represent water, but it's gonna represent heat when a warm front is coming in around any part of the world. Because most of the time when these kind of fronts come in, not only do they affect that part of that region, but they normally transfer to other parts of the world. So right here, you can see it moving like this. See a stream coming through the cloud, because the heat, even though it goes over the clouds, it could be cold over on top, but it's pushing out the warm part. So it's pushing in. Okay, and so this represents how it gets warm, and then this could be like around this half, could be one region, and then it's pushing in. Even though it might not be as dark, it's still pushing into another region. So that represents how, no matter what, it always transfers to around the world. It's not just going to be in one part of the world. And so that's part one of this experiment, and I'm going to do part two. Alright, so I'm just going to explain what's going to be going on for this experiment. I've already got like the warm front pushing in, it's already coming in, and it's already passing through because it's getting a lot lighter even at top. So basically what I'm going to do for this part is I'm going to use this heater to heat it up. And originally this is really cold water. I put it in as cold as it could be. And I'm going to put it next to the heater for a while. I'm going to do a time lapse. And then before it was too cold to where my thermometer would not see the temperature. So what I'm going to try and do is heat it up to where it can show how warm can be, how warm it will be from compared to top to bottom. And then, so I'm going to go in and do the time lapse, and I'm going to do it in, just in movie order probably. Alright, so it would take a while for it to fully heat up. So what I'm going to do is I'm going to hold it right here, and I'm going to check the temperature while it's around right here. Okay, so what I got was, I don't know if you can see that, but it says 95.7. So that shows how warm it can push in easily. So this went from not being able to detect it based on how cold it was to 95.7, which is normally what we have in middle summer days. And so that just shows how hot it can be no matter where it's pushing through. Now I can check it again. I'm going to try and check it with the difference from top to bottom. Oh, it's right here. So I'm going to try the temperature right here. At the top it's 95.8. Okay, and I'm going to do it one more time at the bottom. And it was 94.2, which is over about nearly 2 degrees less. So that shows that even though it might not keep its full effect on going through, it still pushed in all around the whole thing. So that was my second experiment.